Thanks, Craig, for the introductions. For next 12 to 15 minutes, I will be talking about our approach to the disaggregated cloud-native BNGs. We use the TR459 for our disaggregation and kind of give you some idea what does it look like and where we see the benefits of it are. Before I go into BNG discussion, a quick plug-in on Benu. So we've been in existence for since 2010. We're based in Boston, Massachusetts, and very much engineering-driven company with about 80% employees are engineers. We provide edge network functions, and our mission is to simplify them as much possible for the service providers. Our focus has been on fixed line services, for which we have developed a software platform. We call it SD Edge, that's in the middle box here. In a sense, it's a subscriber management platform. We provide WAG and TWAG functionalities, BNG functions, and now we started to work on more the wireless wireline conversions with 5G AGF functionality. The same platform offers SaaS services that can either be enabled on the BNG or can be run separately as a SASE gateway. Now, what happens is when it's a SASE gateway, it exposes some RESTful APIs to the northbound cloud so that we can provide IP-based services like security and parental control from the individual homes for the individual homes and businesses. Also, since the definition of edge is very fluid, the same software, we can package it into a small UCPE that can go all the way to the prems, business prems, or could be a very big data center as a cloud application. As I mentioned, we have been in existence for more than 10 years and have product deployed all over the world. Our solution handles about 7 petabytes of data per day, and over 24 million homes and businesses are connected with our platform. So what we see, BNG Needs, we see the consumer standards and expectations from the networks are shifting rapidly as the world evolves. With the recent shift to work from home, as most of us are doing it right now, the boundaries of enterprise-grade network and the home network are merging. Residential consumers need good quality, reliable, and secure connectivity that they expect from an enterprise network. And enterprise need cost-effective solutions to measure employee productivity and migrate any phishing and mitigate any phishing or malware attacks directed at their distributed workforce from any of the access network. Now, we're also seeing an IoT explosions in our homes and businesses. In my home, I have about 860 devices now, and many of them I don't even know what they are. So it's very easy to see like it's 100+ devices coming in the home, and all these new devices requires its own slice, preferably, and its own security considerations within the home to make it them more secure. And lastly, most of us have been streaming services now, and more these services are coming up. Over-the-top services are being added. So all these new requirements for home and business network, along with new value-added services like augmented reality, gaming, it will put pressure on the fixed network. And the next generation fixed network needs to be able to service these demands and yet be flexible and cost-effective. While there's a big network demand is changing, I do see a major technology transformation happening within the service provider network. Wireless teams who were very much focusing on the mobility and reach with 4G, and now focusing on bandwidth and services for 5G, where wirelines were most focused on bandwidth capacity and availability, now looking more into in-home coverages with Wi-Fi 6 and 6E, but also looking into providing all these new network services from disaggregated BNGs. And cloud player, which used to focus on service delivery at the over-the-top solutions, are really moving towards network services and moving towards the service providers' data centers. AWS has announced Outpost, Google has announced Anthos, Azure has Azure for Operators. So all these technology transformations and the new network needs fits very well with the disaggregated BNG architecture that is based on the TR459 and looks something like this. The control plane runs at a centralized data center and talks to the user planes over PFCP. One control plane can handle many different millions of subscribers, while the user planes could be hundreds of these user planes talking to the single control plane over this PFCP protocol. The control plane takes care of subscriber authentication, subscriber service policies, any IP address management, and becomes a single accounting and analytics plane for any northbound entities that requires to look into deeper into the subscriber information. While the user plane stays more closer to the subscribers and doing all the packet processing and service execution. So any kind of services that needs to be that needs to apply onto the packets remains on subscriber packets remains on the control plane and not goes to the user plane. So its user planes only sends like selected traffic to the control plane based on the PFCP messages, and only when there's requires some subscriber state information. So PPPoE tunnels and IPoE tunnels are all terminated at the user plane, and none of this traffic really goes up to the control plane. Now, since BNG user planes are running closer to the edge, it needs to serve much smaller subscriber set than the control plane. So our BNG can run on the COTS platform. The BNG user plane can run on COTS platform or as a container network function in an edge cloud environment. You simply have to provide some cores and memory, which mostly is based on the throughput requirements for the subscribers. When the user plane boots up, it connects to the control plane and gets armed with its role in the subscriber management, and it's ready to take subscriber traffic. Since no subscriber information is configured at boot up, user plane bring up becomes very simple and very flexible. It is easy to add more user plane and make them part of a service on need basis. Also, we designed our BNG user plane in a way that it can be augmented with hardware smart NICs or smart switch that can run BNG pipeline. In both these cases, the user plane agent, the controller that's talking PFCP to the control plane, it remains the same. So from the control plane point of view, it does not see any difference between the switch-based user planes or a software-only user planes, right? So I can see in the production environment, there are a mix of switch-based user planes, software-based user planes, and also the incumbent user planes that supports the TR459 as part of one service. One of the key benefits for CUPS model is that when you enhance user model is that you can enhance users experience and at the same time can cut the cost. With the segregation of hardware and software for both the control and user plane, you can see a saving up to 75% on the CapEx side. And the OpEx side, the control plane is designed as a cloud application. Many of these cloud and Kubernetes operation efficiencies like scale up and scale down, and the switch over and switch back can be applied and has no impact on the user plane and the subscriber services. Also, with the TR459, user planes are not pre-provisioned, as I mentioned before, with any subscriber information. So it really helps in creating flexible operations and resiliency models, where many of these user planes are backed by a very few backup user planes. And also you can do a mix of hardware and software user planes under the same Cloud BNG service. In the diagram here, I'm showing a mix of centralized and distributed user planes. They can be placed at the most optimal places in the network based on the service requirements. For example, the low latency applications would require BNG user planes to be closer to the customer. the CDN traffic efficiencies that can be done by placing user plane at a network optimal places, while the basic internet service user planes can be more centralized if needed to be, right? All these efficiencies, network optimization, and the mix of user plane types can cut operation costs anywhere from 25 to 30 to 80%, and at the same time provides a much better user experience by quickly failing over, by supporting new services like low density slices within your network. So one of the benefit of being able to move user plane closer to the subscriber edge is with the CDN services. As we all start to stream Netflix and other over-the-top streaming services, about 80% of the busy hour traffic is media streams now. With the existing monolithic BNG, all these individual streams are passed from the CDN that is sitting behind this in the BNG in the data center, which really means is like a lot of duplicate traffic is going out from data center to the individual homes and filling up all the pipes. By moving the BNG closer to the customer and putting smaller CDNs at the edge, it can significantly reduce network savings, network needs. Since control plane is already centralized, there is no impact on the subscriber management and policy that can be moved. Also, you can future-proof your investment by providing MEC and 5G-enabled services from the same edge location that I'm showing it here. So on the final topic, like what we are seeing here is there's a lot of discussions on 5G and convergence recently. And we do see a lot of benefits moving towards convergent architecture. Having one policy plane for both fixed and mobile network can create new revenue models and services that are very sticky to the end customer. With many of the workforces, again, like we are working from home now, either partly or full-time, it's going to remain, we're going to continue to do that, either partly or full-time. A converged network can provide consistent business-like services to the employees anywhere. So with 3GPP and Broadband Forum working closely, the disaggregated BNG in the fixed line standard to look very much like an AGF and a UPF function that's needed for the fixed convergence. So what I mean by that is on top part, I'm showing the 5G mobile network where 5G UE connects to the core, shown in the green above, and the bottom section depicts the fixed line access where residential gateway connects to the BNG to get the data service. In the converged access scenario, the BNG gets modified to AGF and the UPF functions and connects to the 5G core for service enablement instead of a AAA. BNG, the AGF looks like a G node B for the 5G core, and that provides authorization functions for both FNRG, like the fixed line network RGs, existing RGs, and the newer 5G RGs. So there's no changes required on the FNRG side because they're still doing their PPPoE or IPoE connection back into the AGF, which used to be a BNG. Now, the requirements for the UPF for fixed line are different from the UPF for mobile network side because of throughput, the edge cost needs, and all the MPLS and enterprise routings that the BNGs already have. So the best of the breed, what we believe is the best of breed UPF may not be the best of breed UPF for the mobile UPF may not be the best of breed for the fixed line side. So eventually, we do see these two merging together, the AGF and UPF coming together. It does help, like there's no need for an N3 tunnel in between the two, especially if they are running in the same location. So touching only packet once can definitely reduce the overall core requirements and the CPU power requirements. So there's a lot of exciting work coming with the convergence, which is all based on this disaggregated BNG that we have built. With that, thank you.
Open up for a very short Q&A, and if the panelists could keep their answers distinct, that would be very good. Ajay, one for you that's here. Do you believe the software-based user plane can be based on VMs? Either is it better to rely on containers?
Good question. We've been working on this the software-only user planes for a while now, and work very close with Intel, and seen the movement of from virtual machines to the containers. So in short, it really from a user plane point of view and from thinking from performance per core, it does not matter between virtual machines or the containers, as long as you have the right interfaces and you can enable those hardware the abstraction layers for those interfaces between your containers or user planes, then the performance-wise, it should be the same. And so we do support we will build containers because it's easy to package containers into virtual machines for deployments, and also the same software can also run in the COTS when there's no virtual machines. So that's why our choice was containers, because it's easy to port into different packaging.
Okay, thank you. Maybe a question open to all of the panelists here. We talk a lot about disaggregation, and it is a new way of working. With most service providers out there, unless they're in a greenfield environment, have a lot of legacy investment, whether that's BNGs or whatever service management equipment. How are we aiding a migration strategy more than a revolution strategy? And I think, Kurt, you touched on this a little bit as well. How do we offer the migration more than just move straight away into an SDN cloud-enabled CO?
Yeah, sorry, I was on mute. I indeed. So where to start? Actually, it will all depend on the context and the business context of the operator, of the customer. Whether it's greenfield or whether it's brownfield, whether it's introducing a new network or it's actually growing a new network. So we do believe that actually it's very important to what we call to support coexistence. Coexistence where actually you evolve to an SDN MNC paradigm controller, which is actually supporting both the traditional as the SDN native devices, if I may so. And that actually creating a foundation, a baseline to abstract this to the upper OSS BSS. For the OSS BSS, it will also go incrementally. It might be that, for instance, moving to SDN, it's only done for fulfillment, it's only done for assurance, it's done for the combination of the two. And what we have learned as well the last, let's say, 1 to 2 years, is that there might be use cases once you're in an SDN MNC control context, which is multi-vendor, which is supporting as well the coexistence with traditional networks, that you could actually, without migrating them, SDN enable, for instance, using the data telemetry as provided by the traditional networks, feeding that, streaming that in a common data lake, and actionizing that to the traditional network through traditional interfaces. So it all depends, customer by customer, the business case, the use cases, because there are many business cases. Is it multi-vendor networks? Is it moving to AI, ML? Is it a virtual OMCI? Is it decoupling ONU from OLT? So it all depends a lot, and it all requires, I think, a deep discussion and well understanding of the customer context and its vision of how to evolve the network to SDN. And there will be no fit for purpose for all purpose. That's what we believe.
Yeah, I think that's that's obvious that every network is slightly different. So every service providers are in slightly different places and have slightly different needs, as I think Meng Meng presented with the CUSP and the China Mobile example. I'd love to ask more questions. I apologize that we have overrun by 10 minutes now. So all it's left for me to do is thank not just Ajay, Meng Meng, and Kurt, but all of our panelists today for some great presentations, some really good conversation as well. If you want to follow up, then please do with our panelists or via the Broadband Forum. You can contact us at info@broadbandforum.org. And just to wrap up, not just today, but our whole summit, once again, thank you to all of our sponsors. You have made this event possible. You have made it free to attend. So your sponsorship is greatly appreciated. Thank you so much. And you can see all of our sponsors named there. And if you're interested in other Broadband Forum events, our next one is actually happening next week. It's part of our state of play on fiber access, where some of the presenters over the last 4 days will be presenting again on future PON technologies. What's next after 10 gig XGS PON, etc. So join us on May the 20th for that webinar. And that's it. Thank you very much for your attendance. If you're interested and missed any of our sessions, we will be sending out an email very, very shortly with links for you to download the recordings, as well as the PDF of the slides. All I will wish you is a great rest of your day and a great rest of your week. And hopefully you'll join us on the next Broadband Forum event. Thank you so much for your time. Bye-bye.